Hi class, let's take a look at problem 10. Now in problem 10, we're given a function and one of the restrictions that they're putting is that the function has to be greater than 0 and technically 1 to 1. The 1 to 1, remember that the function has to pass the horizontal line test. Now let me start by letting the values of y is equal to f of x, and then this is going to give us the following as we technically find the inverse of this function. And this is going to be that y is equal to 1 plus 1 over x. Now remember that as we find the inverse, well, we have to replace the x for the y's. So replace y by x and x by y, which is going to make a little bit of a mess. So let me just rewrite it. And at this point, we're going to have that x is equal to 1 plus 1 over y. And then at this point, we're going to solve for y. So let me just put it as a comment. Solve for y. So our first step to solve for y, it's going to be to subtract the 1. And we'll end up with x minus 1 is equal to 1 over y. And what I'm going to do here is I'm just going to use negative exponents. So technically raising it to the negative 1 and raising it to the negative 1. And what this is going to give us is that 1 over x minus 1 is equal to y. And this happens to be our inverse. And let me just write it as y is equal to 1 over x minus 1. And in this case, f inverse of x is equal to 1 over x minus 1, where y is greater than 0. Now, the last comment here, it's a little bit tricky because you have to go back to the original statement and you almost have to take a look at the graph. So in this case, the original statement says x is greater than 0. And remember that at some point, as you find the inverse, the x and the y's get replaced by each other, so they're going to basically flip. Now, this part is justified by the following, and I'm putting in here the graph of it. And remember that, well, if your x's and y's get replaced, and then also one of the properties by inverse functions is that they're symmetrical along the y is equal to x function. That means if one function has 1, 2, its inverse, it's unique, and it's going to have 2, 1. The idea of x greater than 0 is to not have the other portion. So as you're finding the inverse, that has to be adjusted. This is so that every coordinate point flips as it passes the horizontal line test. And remember that the inverse functions happen to be symmetrical along the line y is equal to x. So your final answer has to have that final disclaimer. That's actually it for problem 10.